Good morning to one and all present here. Myself Andrea Preeti from BSc A section. Today my seminar topic is Introduction to Process Synchronization. What is process synchronization? So, the definition of process synchronization is coordination of processes to ensure the correct sequence of execution. When the sequence of execution is about to process, the coordination between that is known as the process synchronization. An example for this is synchronizing access to a shared resource. Why is process synchronization important? It prevents data inconsistency. The data will be always consistent and ensures the page program execution. Which page program is executing, it's having a link between it and avoids race conditions and deadlocks. Deadlocks is not present in this process synchronization. Next, we are going to see about critical section problem. Definition for this is a segment of code where shared resources are accessed. So it is a code in which there are many resources which we will be able to access in that is known as critical section problem. And the issues faced in this is ensuring mutual exclusion, progress and bounded waiting. We have to wait for the critical section to do the execution process. Then now we are going to see about race condition. Race condition definition is a condition where the outcome depends on the non deterministic order of execution. So in this the condition it depends upon the non deterministic order of execution. When there is a or when there is a execution happening in it, there should be a condition so that if whether the condition satisfies, then only it will be done the race condition. The example for this is two processes updating a shared variable, where in this condition where only there is only one variable and two processes needs the same variable. This is known as race condition. The next one is mutual exclusion. Definition for this is ensuring only one process accesses the critical section at a time. Mutual exclusion is only one process should be in the critical section when there is an execution. If there are two to three processes in the critical section while there is an execution happening, then it will lead to a deadlock. The techniques used is logs, semaphores, monitors. First we will see about semaphores. Semaphores definition is a signaling mechanism to control the access. There is a mechanism in which we have to control the access of the processes. The types of semaphores is binary semaphores. Binary semaphore is also known as mutex semaphore, and the second one is counting semaphore. And the examples for this is producer consumer problem. Already we have seen about it. Monitors. Monitor's definition is high level synchronization construct that allows safe sharing of an abstract data type. When there is an abstract data, that should be always been private, it should be hidden from the public users. Only the authorized users should be using it. So the high level synchronization allows the safe sharing of the abstract data. The properties is mutual exclusion and condition variables. Now we will see about deadlock. Deadlock's definition is a situation where a set of processes are blocked because each process is holding a resource and waiting for another. Deadlock happens in our day to day life also. In this deadlock is when there is a process to be processed in the critical section and it is holding a resource and waiting for the other one. The other one is also waiting for catching hold of a resource and waiting for the other one. Both are not ready to give up and they want to do the execution now itself. There occurs the deadlock. Necessary conditions for this is mutual exclusion, hold and wait, no preemption and circular wait. Deadlock prevention and avoidance. How we can prevent the deadlock? Prevention is ensuring at least one of the necessary conditions for deadlock cannot hold. So if we prevent this from the deadlock, so deadlock will not be happening. Avoidance, we have to avoid deadlock, so we are using algorithms like bankers algorithm to ensure system remains in a safe state. When there is many deadlock happening, system is unsafe. Real time examples for this is operating systems handling multiple users and process. Databases is transaction management and concurrency control. So using this and all, we are doing the process of synchronization. Thank you everyone.